Oh, I see more are coming in. Welcome. Okay, so for today, I actually have my headset plugged in. So let's test the audio. Can someone unmute and talk? I just want to make sure that I mean,
Testing.
okay, perfect. Yes. And please put the audio check on your end in the chat so I know that it's working for all students. Thank you. Very good. Okay. Great. Okay, so we have already finished the exam 2 material because exam 2 covers up to section 4.2. And remember, our exam is at the end of this week, Thursday, July 8th, 8:05 to 10:05 a.m. And that exam 2 is going to cover 2.3, 2.4, all of chapter 3, and then 4.1, 4.2. The details of the exam, I will send that out through email later today, and then we will review them tomorrow. But we have discussed that for exam 1, it was done through My Math Lab. For exam 2, it's going to be done free response. Also for exam 2, students are allowed to have 1 page of notes, front and back. Okay, so all of that will be put together in the email, and then we will discuss that in class tomorrow. But remember, we've already finished the exam 2 material. Today we'll be moving forward to finish chapter 4 and continue with our content. Okay. Okay, so in chapter 4, we learned about inverse trig functions. Learning about inverse trig functions allows us to solve trigonometric equations. The core 3 steps that we have are listed here. So we isolate our trig function, find the solutions in 1 period. So if we're working with tangent and cotangent, find the solutions between 0 and pi. If we're working with sine, cosine, cosecant, secant, find the solutions between 0 and 2 pi. Then our step 3, we add period times k to each solution, which will generate all solutions. Those are the core 3 steps. Before we go through those 3 steps, we want to check, are they asking for all solutions or specified solutions, and are we in degrees or radians? So those pre-steps will help you determine how they want you to answer. But regardless, we do need to go through step 1, 2, 3. You might think, if they only want solutions between 0 and 2 pi, why do we even need step 3? And you're going to see why in the next section. Remember that always go through step 1, 2, 3, and then from there you can determine how you want to express your answer depending on the instructions. Okay. So in section 4.3 and 4.4, we are going to have problems that are a little more challenging than we saw in 4.2, but we're following the same steps. So let's start the 4.3 recording.
Recording in progress.
Okay, so this recording will cover section 4.3. Okay, so in section 4.3, we are going to complete the same core 3 steps. So that's isolate the trig function, find the solutions in 1 period of the input, and then we're going to add period times k to each solution. So see section 4.2 for those instructions. After we go through those 3 steps, then we isolate x. Okay, so isolate x is going to come last. We have to solve for the input first, and then we can isolate x. So it states here, first, solve the equation completely for 2x. So that's following step 1 through 3. And then second, solve the result for x. So this is the extra step 4. Okay. In the first example, the instructions state, find all real numbers that satisfy the following equation. So from the instructions, we know that we want all solutions and that our solutions are in radians. So let's make a note that for this example, we should be in radians and we want all solutions. Those are the pre-steps. We call them the seatbelt step. Put on our seatbelt before we start driving. So we do need to check the instructions before we start our solution here. Okay, so now we can go into the core 3 steps. Step 1, isolate our trig function. Our cosine of 2x is equal to negative root 2 over 2. Step 2 is we want to find the solutions for the input in one period of the trig function. So one period of cosine, that's between 0 and 2 pi. Let me move this over. So I think it's helpful to draw the circle. Okay. Okay, it's not letting me move this. That's okay. We'll just draw a smaller circle here. Okay. Remember that on the unit circle, cosine is the x coordinate. So negative root 2 over 2, that's about negative 0.7. So that would place us about here. Okay. So let's start with Jacob. Jacob, what are the two solutions for 2x that are between 0 and 2 pi?
Sorry, could you repeat the question? You kind of cut out for me.
Okay, yeah, let me say that again. What are the two solutions for the input 2x that are between 0 and 2 pi? So this is saying cosine of 2x equals negative root 2 over 2. We
Okay.
draw that on the unit circle, and then now we want to identify the radian measures that satisfy cosine of input is equal to negative root 2 over 2.
Would that be 3 pi over 4 and 5 pi over 4?
That's correct. Great. So notice that we're solving for 2x. We're solving for the input using the 3-step process. Very good. Okay. Step 1, we isolated trig function. Step 2, we found the solutions in the first cycle of cosine. Step 3, we add period times k to each solution. So now we've completely solved for 2x. We got all solutions for 2x. And then now in section 4.3, we have an added step 4, which is isolating x. Follow the core 3 steps, and then we have an extra step 4, which is isolating x. That's our extra step 4. Okay. To isolate x, we need to divide both sides by 2. Recall from algebra that when you're dividing by 2, that's the same as multiplying by 1/2. Let's make a note here. Dividing by 2 is the same as multiplying by 1/2. Okay, because when you divide by 2, you multiply by the reciprocal of 2. Reciprocal of 2 is 1/2. Okay, so when you multiply by 1/2, you need to multiply all terms by 1/2. So 3 pi over 4 times 1/2, that's 3 pi over 8. 2 pi k times 1/2 is just pi k. Note that in your homework, instead of pi k, it may say k pi. Multiplication is commutative, so pi k is equivalent to k pi. Okay. The second line, 5 pi over 4 plus 2 pi k. When we multiply that by 1/2, we get 5 pi over 8 plus pi k. So now we found all solutions for x. Okay. When we went through the 3 steps, we went through the 3 steps to solve for 2x. So notice that the period for cosine is 2 pi. We're not looking at the period for cosine of 2x. We're looking at the period for cosine of input, the parent function, because we're just solving for the input. Okay, so we would read the equation as 2 times cosine of input, close parentheses, plus square root of 2 equals 0. Solve for input first using the core 3 steps, and then the added step 4 is isolate x. If we try to isolate x prematurely, what happens is we'll end up missing solutions. So you need to solve for the input first, and then make sure isolating x is your very last step. Okay. So students, why don't we give it a try, part B? Let's put our skills to test right here, and please DM your answer. So I know that we're together. Type in a W for working once you've started on this problem. So you're going to go through the core 3 steps to solve for 3x. Then the added step 4 is isolate x. When you're finished, please send me the answers in my DMs. And then W means you're working and on task. Appreciate the participation in the chat bar. Okay, very good. I see that we're on task. So you'll send your answers to me directly once you have all solutions for the equation in part B. Okay, I see some solutions coming in. Let's keep working for a couple more minutes and then we'll bring it together. Okay, great. I see more answers coming in. So let's go through the solution together. We will start with Miguel, then Hector, then Genesis. Okay. Okay, so Miguel, help us with step 1. What do we have after we isolate our trig function? That's right. We have to add 2 to both sides and then divide both sides by 4. So we get sine of 3x is equal to 1/2 after we simplify. Correct. So sometimes that step 1, we can get it right away. Other times it's going to take a few more steps to isolate the trig function. Very good. Let's move on to Hector. So Hector, looking at our unit circle, at what radian measures is sine of the input equal to 1/2?
You have pi over 3 and 5 pi over 3.
Let's check that again. So remember, sine is the y coordinate. And so we'll put in the y coordinate is 1/2.
My bad, it's pi 3 over 2 and negative pi 3 over 2.
Let's check. So we're solving for the input 3x, and we look on our unit circle, sine is the y coordinate. So the y coordinate is 1/2 here when our vertical leg is short leg. So what group is long short in? This measure right here, Hector, what does that radian measure look like? Or you can tell me what you think it is in degrees,
Okay,
and then we can help you convert it into radians.
pi over 6.
Radians, very good.
Yes.
So we see that when sine is 1/2, which means when the y coordinate is 1/2, our input, our radian measure, is at pi over 6 or 5 pi over 6. So 2 solutions for the input in the first cycle of sine is pi over 6 and 5 pi over 6. Great. So Genesis, what's next? What's our step 3 to solve for the input?
So we need to solve for x.
Not yet. So remember, solving for x, that's the last added step 4, but we're still on the central step 3-step process.
We need to add 3 pi k to pi over 6 and 5 pi over 6.
We add period times k. So what's the period for our parent function sine?
Is it 2 pi?
Yes. Remember, for sine and cosine, the period is 2 pi. For tangent, period is pi. And then reciprocal functions fall. So cosecant follows sine, secant follows cosine, and cotangent follows tangent. Yes, so you add 2 pi k to each solution. Okay, so right here, we did what we did in section 4.2. 4.2 is part of our exam this Thursday. We solve for the input by following the 3-step process. Now our extra step 4, when the input is not x, we have an added step 4, which is isolate x. Okay, so we have to divide everything by 3. So dividing by 3 means multiplying by 1/3. So we get pi over 18 plus 2 pi over 3 times k. And then we have 5 pi over 18 plus 2 pi over 3 times k. So to get x by itself, we need to multiply both sides by 1/3. And now we have all solutions for x. Okay. Are there any questions in how we were able to isolate x using the core 3 steps and then our added step 4? Okay, great. Let's go to Stephanie and Justin to help us with part C. So Stephanie, step 1, we want to isolate our trig function. What do we have here?
So we would have tan of 4 alpha is equal to negative square root 3.
That's right. And Justin, when we see this, is this a value that we have on the unit circle?
Not on the unit circle, but it's tangent. So it would be 2 pi over 3 and then 5 pi over 3 because it's a negative. So negative 3 pi over 2 divided by 1/2 would be negative 3 radical 3.
Yes. So although it's not one of the coordinates on the unit circle, it is, we still consider it on the unit circle, as in the radian measures on the unit circle. We don't have
Got
to
it.
use our calculator. So yes, very good. Okay. Remember though, since the period for tangent is pi, we just look for solutions between 0 and pi. And Justin mentioned that at 2 pi over 3, so we'll put right here, at 2 pi over 3, notice that horizontal leg is short, vertical leg is long. So this is negative 1/2 root 3 over 2. And Justin chose quadrant 2 and 4 because tangent is negative in quadrant 2 and 4. But we're just looking at the solution in quadrant 2 really because we're finding between 0 and pi. Okay. And then if we're not sure, we can do some side work, and we see here that tangent of 2 pi over 3, tangent is y over x. So when we do root 3 over 2 divided by negative 1/2, it simplifies to negative root 3. So remember that if you're not confident, you can do some side work. And we see, indeed, at 2 pi over 3, the tangent is equal to negative root 3. So our input solution between 0 and pi is 2 pi over 3. Okay, that completes step 2. Let's go to Esmeralda. And Esmeralda, if your audio isn't working, let us know in the chat. What is our step 3 here? Because remember, we need to solve for 4 alpha first before we solve for alpha. Step 1, we isolated tangent. Step 2, Justin helped us find the solution between 0 and pi. Now, Esmeralda, what is our step 3? And Esmeralda, again, if your audio isn't working, please answer in the public chat so we can see. Now, if we forget that tangent has a period of pi, and we end up finding the solutions between 0 and 2 pi, what will end up happening is you'll see that your solutions overlap. Esmeralda, yes. So we're asking, after we isolated the trig function, we found the solution between 0 and pi. What is our third step in solving for 4 alpha? Because we have 3-step process to solve for the input, and then our added step 4. So what is that step 3? And Khalid, I didn't get a response from you earlier, so if your audio isn't working. Khalid and Esmeralda, I'm not hearing from you. Please say something in the chat so I know that you're with us. And then can a volunteer chime in? What is our step 3?
You add pi k.
Yes, the reason why we add pi k is because the period for the parent function for tangent is pi. Very good. So you add period times k to generate all solutions for the input. Okay, so Esmeralda, if we were working with sine or cosine, yes, we would add 2 pi k. But now that we're working with tangent, we add pi k because you're adding period times k. Period for sine and cosine is 2 pi. Period for tangent is pi. Okay, great. So we found all solutions for 4 alpha, which is necessary before we solve for alpha. So now we can solve for alpha. If we don't go in this order, 1, 2, 3, 4, we may be missing solutions. So let's divide everything by 4. We get 2 pi over 12 plus pi over 4k. And then always express your answer in simplified form. Alpha comes out to be pi over 6 plus pi over 4k. This should actually read pi over 4 times k. Okay, before we move to the second page, let me know if there are any questions with solving these trig equations when your input is not x. You really still follow the same 3 steps to solve for input, and then the added step 4 is isolate x. We multiply both sides by 1/4 here to get alpha by itself. And then we distribute. Very good. Yes. So when you're dividing by 4, that's equivalent to multiplying by 1/4. Great. Okay, so let's move on to the second page. There's going to be one problem that kind of ties it all together for you to try. But first, let's see our pre-steps. They tell us to find all real numbers in the interval between 0 and 2 pi. So this time we have specified solutions. We're still in radians. Okay. Those are observations we want to make before we start the problem. So we know whether we're working in degrees or radians and whether we are finding all solutions or specified solutions. I'm going to make an important note up here that when you're looking for specified solutions, first, you do need to find all solutions. Find all solutions. And then you express the answers that are in the specified interval. If you try to jump to find the solutions from 0 to 2 pi, many times I see that we miss solutions. That's a very common error, and I'll point that out in this problem. Okay, so I'm going to put a pink on this box to draw attention. First, we need to find all solutions. Okay, so we know how to find all solutions. We follow the core 3 steps to solve for the input and then isolate x. So here, step 1, isolate cosine. Okay, so cosine of x over 2 is equal to 1 over root 2, which is root 2 over 2. We immediately recognize that this is on the unit circle. On the unit circle means we don't need our calculator. The input is a radian measure on the unit circle. Okay, so our x coordinate cosine is the x coordinate on the unit circle. X coordinate is root 2 over 2. This is in our twin group. So that's, let me make sure I'm in the right quadrant. Yes, we're in quadrant 1 and 4. So that's at pi over 4 and 7 pi over 4. So step 2, we're finding the solutions between 0 and 2 pi, the first cycle of our cosine function. And those solutions we can see on the circle are pi over 4 and 7 pi over 4. Step 3, we need to add period times k to each solution. So the period for cosine is 2 pi. We add 2 pi k to each solution. And now we have all solutions for x over 2. Okay, Miguel, this time, how do we isolate x? What do we do to both sides to get x by itself? Very good. Let me see if I can move, shrink and move this. Would it let me? Okay, I think we can fit that. Very good. Yes, so we're going to multiply everything by 2. So x is going to be, so times 2 times 2 times 2 times 2. That's going to be pi over 2 plus 4 pi k. Okay. And then this is 7 pi over 2 plus 4 pi k. Okay, there we go. I wanted to squeeze it in here. Yes, because we're not done yet. So actually I shouldn't box that yet because it's not our final answer. This would be if they're asking for all solutions. That would be your answer if they ask for all solutions. We isolated cosine. We found the solutions for the input between 0 and 2 pi. We added 2 pi k to each solution, and then the extra step 4, we isolated x. Okay. Next, what we need to do when they ask for specified solutions is we need to plug in k values so we get solutions between 0 and 2 pi. Okay, so since we have a denominator of 2, let's rewrite 2 pi with denominator of 2. 2 pi is the same as 4 pi over 2. 4 divided by 2 is 2. So 2 pi is equivalent to 4 pi over 2. Okay, so now what we do is we plug in k values. We see when k is 0, what are the solutions? When k is 1, what are the solutions? And then we keep going as needed. So let's watch here. We plug in 0, we get pi over 2. Plug in 0, we get 7 pi over 2. When we plug in 1, you may need to do some scratch work up here. When we plug in 1, this is pi over 2 plus 4 pi. And then 4 pi, when we write it with denominator of 2, 4 pi is 8 pi over 2. So when we plug in k as 1, we have pi over 2 plus 8 pi over 2. That's 9 pi over 2. When we plug in k as 1 to the second row, we get, this is 7 pi over 2 plus 8 pi over 2, which is 15 pi over 2. Okay. So these are the 4 solutions plugging in k equals 0, k equals 1. However, we only want the solution between 0 and 2 pi. Sometimes there's multiple solutions, other times only one. Here we only have one because pi over 2 is in that specified interval. The rest of these are not. 7 pi over 2 is not in the interval, 9 pi over 2, 15 pi over 2. And you see that as k increases, the solutions are just going to get larger. So the only solution that's in the specified interval is pi over 2. Okay. And students, for your reference, if you want to see how we got the solutions, what we're doing is we're plugging in k equals 0. So our all solutions for x were pi over 2 plus 4 pi k. 7 pi over 2 plus 4 pi k. We plug in k values to generate specific solutions. I just want to illustrate off to the side here. We would plug in k equals 0, k equals 1 to generate specified solutions. Okay. We have all solutions. Now we plug in k values to get specified solutions. So when we plug in k equals 0, k equals 1, the solutions we got were pi over 2, 7 pi over 2, 9 pi over 2, and 15 pi over 2. However, only pi over 2 was a solution in the specified interval. So the other 3 we threw out. Okay, any questions taking a look at what we did here? We first find all solutions, and then we plug in k values to determine which solution or solutions are in the specified interval given. Okay, your turn to give it a try. Now, this problem may take a little longer than the previous one, so I am going to pause the recording. Try this next one on your own. I will give us a hint that we should end up with 6 solutions. That's the hint. Okay, go ahead and try part B on your own. Let me know if you have questions through the chat bar, and I will pause the recording while we're working on this problem.
Recording stopped.
Okay, so students, we're working on part B. First, find all solutions for x following the core 3 steps with the added step 4. Then you're going to plug in the k values to find solutions that are between 0 and 2 pi. The hint I'm giving us is that you're going to end up with 6 solutions. If you do finish early, remember, open up homework and see if you can utilize class time to get a couple of homework problems done. We do have our exam 2 this Thursday, which means that we have all the exam 2 sections. Those homework sections are due this Thursday by 7:30 a.m. So utilize the time to work on homework if you finish early. We're going to take a few more minutes for this so students can get through the entire solution on their own before we discuss as a group. So students that are finishing early, utilize the time to work on homework. welcome, Jimmy. We're working on this problem. I see a couple students may have missed the first part. So Jimmy, do you want to go ahead and take a screenshot of the first part of section 4.3? Jimmy, can you hear us? Okay. Let's see. Jimmy, can you say something? I'm not sure if my microphone disconnected. I'm not able to hear you. Jimmy, other students, can you hear Jimmy? I'm not able to hear Jimmy, so I don't know if because I'm using my headphones right now.
I don't hear anything.
Oh, okay. Okay. Thank you. Jimmy, can you try to connect to the audio so I can talk to you? Okay, so Jimmy, go ahead and take screenshots here. I'm just gonna put this up. This is the, oops, keeps moving. Okay, let me do this. This is the first page. I don't know why it's moving up like that. Oh. Something is happening here. I think I accidentally pressed dictate. That's not what I want. Students, keep working on part B. Okay. So Jimmy, this is the first page we went through in class today. And then here's the second page. If you're missing anything else, referencing to all students, check in with me after class. Okay, and then once you have a solution for B, send that to me in my DMs. Jimmy, yes, we have, so far we're covering section 4.3, so it's just been those 2 pages. Okay, students, let's come together. Okay, I see that our solutions are on track, but some students are missing a few solutions. So let's bring it together. And then before I start the recording again, if you're able to hear me, please type in a Y for yes, because I think there are a couple of students that I'm not connecting with the audio. So I just want to make sure we're good and to also mark participation for today. So if you're able to hear me, type in Y for yes. Great. I see Genesis, Jimmy, Stephanie, Hector, Justin, Jacob, Miguel, Esmeralda. 2, 3, 4, 5, 6. Okay. Okay, great.
Recording in progress.
Okay, so we'll resume the recording here. And I'm going to call on students to help us go through the core 3 steps to solve for 3x, and then the extra step 4 to isolate x. Once we get all solutions, then we can plug in the k values to find the specified solutions. Okay, so here we go. Let's begin with Jacob. So Jacob, let's isolate sine. What do we have?
A negative square root of 3/2.
That's right. Okay, so sine of 3x is negative root 3/2. Make that a 3. So that is our purple step 1 done. Okay, back to Genesis. So sine is the y coordinate on the unit circle. At what radian measures in the first cycle of sine, meaning between 0 and 2 pi, would sine of that radian measure be negative root 3/2?
4 pi over 3 and 5 pi over 3.
Let's check that. So it's here and here, which is 4 pi over 3 and 5 pi over 3. Correct. Very good. Okay, so our vertical leg is long here at our 60-degree reference angle. So in quad 3 and 4, that's 4 pi over 3 and 5 pi over 3. Okay. So we've solved for 3x, or we got the 2 solutions in the first cycle of our parent function sine. Miguel, what is the third step to get all solutions for 3x? Not yet. So I want to warn us, if we at this step multiply by 1/3 and then add 2 pi k, our solution will be wrong. So what do we need to do before we isolate x? Yes, this has to come before we isolate x, because we need to get all solutions for 3x, and then our fourth step is isolate x. When we go out of order, what happens is that we're missing solutions. Okay, so good that we point that out. Now after we solve for 3x, now we can solve for x. So multiply everything by 1/3, we get 4 pi over 9 plus 2 pi over 3 times k. 5 pi over 9 plus 2 pi over 3 times k. And if we don't get all solutions, if we just jump to specified solutions, we may be missing solutions. So if we just said 3x is equal to 4 pi over 3 and 5 pi over 3 and then divided by 3, we would only get 2 solutions when there's actually 6 solutions that satisfy the equation. So now we're seeing why it's mandatory to always find all solutions first. Once you've done that, then you plug in the appropriate k values to get the specified solution. So you plug in k is 0, k is 1, k is 2, k is 3. And I'll tell you, for this step, you may need to do some side work working with the fractions, or you can use your calculator to help you with the fractions. So when you plug in 0, we end up with 4 pi over 9 and 5 pi over 9. Okay. When we plug in 1, we have to do 4/9 plus 2/3. Our calculator can handle that. 4 over 9 plus 2 over 3, that simplifies to 10 over 9. And then 5 over 9 plus 2 over 3 simplifies to 11 over 9. So when k is 1, our 2 solutions are 10 pi over 9 and 11 pi over 9. When k is 2, we end up with 16 pi over 9 and 17 pi over 9. When k is 3, we plug that in, we get 22 pi over 9. We can stop here because 22 pi over 9 is not in the interval. So when we say we're looking between 0 and 2 pi, if our denominator is 9, 2 pi is going to be 18 pi over 9. So we want solutions between 0 and 18 pi over 9. So let's circle. 4 pi over 9 is in, 5 pi over 9 is in. 10 pi over 9 is in, 11 pi over 9 is in. 16 pi over 9 is in, 17 pi over 9 is in. 22 pi over 9 is out. And in the software, many times in the instructions, it says write your answers in ascending order. So let's do that. X is equal to, these are the solutions between 0 and 2 pi. 4 pi over 9, 5 pi over 9. 10 pi over 9, 11 pi over 9. 16 pi over 9, 17 pi over 9. Another reminder is for these free response exam questions, students are required to show work. If you just have these 6 answers without the work, I wouldn't know where the answers came from. So you do need to show, to receive credit on the problem, you do need to show all the steps that we've been going through. Isolate the trig function, find solutions for the input in one cycle of our function, add period times k to each solution, then isolate x. Once you get all solutions for x, then you can plug in the k values to find specified solutions for x. Okay, are there any questions before we move forward? Let me check the chat. Okay, Stephanie, are you back? Okay, thanks, Stephanie. I had to step away for a moment. Any questions, students, before we move to the last problem? Okay, next we're going to hear from Hector. So it's going to be Hector, Miguel, and then when Stephanie comes back, we'll circle back to Stephanie. Okay, let's work together on this last problem. Sorry, right here. Okay, so Hector, our first step, or actually our pre-step before we even start the problem, is to identify whether we're in degrees or radians and whether they want all solutions or specified solutions. So what do the instructions tell us?
In degrees.
Very good. All angles, this time we are in degrees. Okay. And then we want to find all solutions and specified solutions, so both. But it's important to note that we're in degrees. Okay, let's stay with Hector. Hector, our step 1 is to isolate the trig function. So what is cosine of x over 5 when we get it by itself?
-3/5.
Yes, -6/10 reduces to -3/5. Very good. And is -3/5, is that one of the x coordinates on the unit circle?
Um, No.
It's not. So thank you. Yes. So when we're not on unit circle, we need to use calculator. And calculator could be in degree mode or radian mode depending on the instructions. Here, when it asks for all angles, we do need to make sure that our calculator is in degree mode. Okay, so students, turn your calculator to degree mode. Okay, and then we'll draw our circle off to the side here. We're solving for x over 5. Cosine is the x coordinate on the unit circle. So x is here. This is -1/5, -2/5, -3/5, -4/5. Okay. Let me make it a little more evenly spaced out. So -3/5 is about here. Remember that your calculator is only going to give you the solution in the restriction. So for inverse cosine restriction 0 to pi, it's only going to give you one solution. It's going to give you number 1 here. We need to find number 2. Okay. So let's check our calculator. We're getting the solution for the input x over 5. Our calculator is going to give us the solution between 0 and pi, or in degrees, that's between 0 and 180 degrees. So when we do inverse cosine of -3/5, we're going to get the solution. So this is the solution between 0 and 180 degrees. And that's because inverse cosine gives us the solution between 0 and 180 degrees. Okay. So students, what is the solution for x over 5 between 0 and 180 degrees? And then remember, since it's not a final answer, we do not round. We leave it out. We only round the final answers. Thank you, Stephanie, for letting me know. Okay, students, so put in your calculator. Remember, for step 1, if the radian or degree measure is not on the unit circle, we need to use our calculator. Make sure your calculator is in the right mode. And then when we use our calculator to solve for the input, we use the inverse trig function. The inverse trig function will only give us a solution in the restriction for that inverse trig function. So for inverse cosine, we're getting the solution between 0 and 180 degrees. Okay, let's see what we're getting. Great, looks like we're in agreement. That's 126.8698976 degrees. Okay. Okay, so this is going to be number 1. Number 2. Okay. So Stephanie, going back to section 4.2, which is part of our exam 2 coverage, after we get the first solution for a cosine equation, how do we get the second solution using the symmetry?
We do 360 degrees minus 126.8698972.
Excellent. If we are working with sine, it would be either pi or 180 degrees minus first to get second. Here we're working with cosine, so we use 2 pi or 360 degrees minus first solution to get second. Okay. And we can see that from the symmetry. If we do 360 degrees minus that 126.8, we're going to land on solution 2. So let's see what solution 2 is. This is not a final answer yet. We're still only in step 2, so we do not want to round. when we are in what we call the intermediate steps. This is 233.1301024 degrees. Okay, so we've just finished step 2. We got the solutions between 0 and 360 degrees. Let me repeat. Step 1, we isolated cosine and observed that we're not on the unit circle, so we need to use our calculator in degree mode. Step 2, we found the two solutions in one cycle of cosine. That's between 0 and 360 degrees. Okay, now we're on to step 3. So step 3, we're going to add period times k to each solution. So the period of our parent function cosine is 2 pi or 360 degrees. So add 360 degrees times k. If you put here plus 2 pi k, it would be wrong because we're in degrees, not radians. So we need to shift gears when we're in degrees versus radians. Okay, so there's the 3 steps to solve for the input. Miguel, what is our 4th step to solve for x? What do we need to do to both sides? Yes, so this comes after we get all solutions for x over 5. Then our added step 4 is to isolate x. Okay. Now it does ask for all solutions to start with. Okay, and then later on, we want specified solutions. Okay, but for all solutions, since this is a final answer, we can round at this point. So we take times 5. Okay. It's going to be 634.3 degrees plus 1800 degrees times k. Next, we do times 5 times 5, 1165.7 degrees plus 1800 degrees times k. So since this is a final answer, we are able to round. We'll just round to the nearest 10th there. And then this is the answer for all solutions. We're allowed to round once we get to the final answer. If we are in the intermediate steps, though, do not round. Just take it out to, I'd say, at least 5 places and you're safe. If you're rounding prematurely, you're going to end up with rounding differences. So you want to avoid that. Okay, we got all solutions. Next, to get specified solutions, we plug in the k values. So when we plug in, we start with k equals 0. K equals 0, we end up with 634.3 degrees and 1165.7 degrees. Both of those are not in the specified interval. In fact, no matter what k value you plug in, there are no solutions between 0 and 360 degrees. Okay, so no solutions doesn't mean it's incorrect. What this means is if we graphed our function, cosine of x over 5 is equal to -3/5, it's our parent function cosine of x, but it's been stretched horizontally by a factor of 5. So after it's stretched horizontally by a factor of 5, we don't have any solutions between 0 and 360 degrees that satisfies the equation. Okay, so this is another problem where you're seeing if you're going out of order, meaning if you are just directly solving for x and not getting all solutions, you're going to end up with the wrong answer. You're going to end up having solutions that don't belong or leaving out solutions, either way. You have to follow the steps in the order that it's been presented in order to solve these equations. So we need to isolate the trig function, find the solutions for the input in the first cycle of the trig function, then add period times k to each solution. So those are the core 3 steps to solve for the input. The step 4 in that order is going to be isolate x. Once you've followed those 4 steps, you got all solutions for x. And then afterwards, if they ask for specified solutions, you plug in the k values to list specified solutions. Okay, so I'm going to for a moment bring us back to 4.2 to show us that even in 4.2, we really did emphasize when they asked for specified solutions, notice, we always found all solutions first, and then we looked for specified solutions. Okay, so that's going to be even more important in 4.3, that we start by getting all solutions for x, and then look for specified solutions. So I boxed here in pink here. First, find all solutions, and then proceed on to get the specified solutions. Okay, if we're good to move forward, please type in a G for good. If we have questions, let's bring them to the discussion before we wrap up section 4.3. So I know I probably have been repeating the same steps over and over again, but that's to reinforce them. And we should know them in that order. 1, 2, 3, 4, 4 steps. And then from there, you're going to check, are we answering all solutions or specified solutions? That will be last. Okay, I see Genesis, Justin, Stephanie, Miguel, Jacob, and Jimmy are good to move forward. The students that didn't respond, do you have any questions before we wrap up section 4.3? And if you missed anything from today or previously, stay after class. I'd be happy to share my screen. Okay, so let's stop the section 4.3 recording. This concludes section 4.3.